Welcome back to the channel, and thanks for clicking on this one. If you've been following along with this build, you already know which car we're talking about. The 2013 Porsche Cayenne, 3.0 TDI diesel, CRCA engine code. The same car you've seen in several videos over the past few weeks. The coolant reservoir job, the crankshaft seal replacement with that custom installation tool. Today, we're putting all the pieces together and telling the full story of this repair from start to finish. This wasn't a small job. This wasn't a weekend fix. This was the kind of repair that starts with one phone call from a customer and ends with the entire top of the engine sitting on a clean workbench, every component cleaned, inspected, and sealed properly before it goes back together. So get comfortable, because I want to walk you through every single step. Let me start with how this came to me. The owner of this Cayenne called me about a coolant problem. Not a slow drip, not a once-a-month top-off. This was sudden, noticeable coolant loss. He was adding coolant to the reservoir more often than any healthy cooling system should ever need. And the more he topped it off, the faster it seemed to disappear. He told me the system pressure didn't feel right either. Sometimes when he opened the cap after the car had been sitting, there was almost no pressure built up at all. Other times, the reservoir looked low even after he'd just filled it the day before. Now, on any car, that kind of symptom is a warning sign. But on a 3.0 TDI Volkswagen Group diesel, the engine you find in the Cayenne, the Touareg, the Audi Q7 of this era, coolant loss is almost never a simple hose problem. It's almost always something deeper inside the engine. And experience tells you, before you even open the hood, that you're probably looking at a teardown. So when the car came in, the first thing I did was pop the hood, pull the engine covers, and just look. Before any diagnostics, before any pressure tests, just look at what's happening up there. And what I saw told me the full story before I picked up a single tool. The valve cover gaskets were leaking, both sides. Engine oil was visibly seeping out from the perimeter of both valve covers. And down in the valley between the two cylinder heads, that V-shape area where the intake manifold sits, where everything lives in this engine, was a swamp. A mixture of engine oil and coolant pooled in the valley, mixed together over who knows how many months of driving. Some of it was old, baked on, almost varnished into the metal. Some of it was fresh. Two fluids that should never meet, sitting together, slowly destroying the rubber and plastic of everything they touched. That's the moment I knew. This was going to be a full top-end job. Intake manifold off, EGR system out, valve covers off, injectors out, every gasket on top of this engine replaced, every surface cleaned by hand. And while I was in there, every wear item that you should always address during a job like this was going to get addressed. No shortcuts. No half measures. Because on these engines, if you go in and only fix the leak you can see, you'll be back inside the same engine 6 months later fixing the next one. So that's what we did. Let me walk you through every step. We started with the intake side. The intake manifold came off first. Every gasket on that manifold was replaced. The runner gaskets, the throttle body gasket, the connection seals, all of it. While the manifold was off, we addressed the intake flap actuators on cylinder banks 1 and 2. These are known weak points on the CRCA engine and on the broader 3.0 TDI family. The plastic linkages inside those actuators wear out over time. The motors get sluggish. The flaps don't open and close cleanly anymore. And that creates inconsistent intake behavior. Uneven boost, rough idle. Sometimes a check engine light if the position sensor sees something out of range. Both actuator assemblies were serviced. Now they move freely, they respond properly, and they should give the customer another long stretch of trouble-free operation. Next came the EGR system. And here's something important to understand about the EGR on a high-mileage 3.0 TDI. It's never just one gasket. The EGR valve itself, the transfer plate that connects it to the manifold, the cooler housing, they all share a sealing system, and they all live in the same area of the engine. So when one of them starts to weep, you don't replace one gasket. You replace every gasket in that entire assembly. That's exactly what we did. New seals on the EGR valve, new seals on the transfer plate, and most critically, new gaskets on the engine oil cooler that sits in that same area. Now I need to stop here and explain something, because this is one of the most important parts of the whole repair. The engine oil cooler on this platform is a known failure point. When those oil cooler gaskets fail, and they do fail almost predictably somewhere between 100 and 200,000 kilometers, they create a path between the oil circuit and the coolant circuit. Oil starts pushing into the coolant system under pressure, or sometimes coolant starts seeping into the oil. Either way, you get cross-contamination. And cross-contamination is exactly what creates the kind of mess we found in the valley of this engine. So replacing those oil cooler gaskets wasn't optional. It was the entire reason this repair existed. We also replaced the gaskets on the coolant bypass valve. This is a smaller component, easy to overlook, but critical to the cooling system's pressure behavior. If that bypass valve leaks, you lose coolant slowly through the EGR cooler circuit, and you'll never find that leak from above because it drips down internally where you can't see it from the engine bay. New seals on that valve too. Then we got to the EGR valve heat shield housing, and this part, the plastic housing on the heat shield, was cracked, completely compromised. Heat-stressed plastic that had finally given up. That alone could have been contributing to the coolant loss, depending on where exactly the crack was. So we replaced the entire heat shield housing with a new unit, clean, intact, ready for another decade of thermal cycling. Now, while the top of the engine was wide open like this, you do every other maintenance item that lives up there, because you're never going to have better access than you have right now. Skipping these things would be a mistake. So we pulled all 6 glow plugs, replaced them with new ones. And while the plugs were out, we cleaned the glow plug channels in the cylinder heads. Diesel engines build carbon in those channels. That carbon traps the glow plugs in place over time, and when the plugs eventually need to come out, 5, 6, 7 years from now, they break off in the head, and then you've got a much bigger problem. So we clean those channels now. We give the next person a fighting chance, even if that next person is me 3 or 4 years down the road. The injectors. All 6 were removed, inspected, and cleaned. We checked the spray patterns, checked the sealing surfaces on the nozzles, checked the condition of the bodies. Everything was within specification, so we cleaned them up properly and prepared them for reinstallation. When the valve covers came off, and they had to come off because that was the original leak source, we replaced the valve cover gaskets with new ones. New rubber, new fit, proper seal. We also replaced all 6 of the injector sealing grommets that live inside the valve covers. These are the rubber seals that wrap around the injector body where it passes through the valve cover. They harden over time, they shrink, and when they do, oil from inside the valve cover seeps down into the glow plug wells and the surrounding area. New grommets all around. That problem is solved for years. We replaced the heat shields on the injectors. 6 new heat shields, properly oriented, properly seated. These shields protect the injector tip from the combustion heat that comes back up through the cylinder head. Original heat shields get distorted over the years and lose their sealing efficiency. New ones bring everything back to factory condition. We replaced the injector hold-down bolts with new fasteners. This is non-negotiable. These bolts are torque to yield. You torque them once, they stretch into their final position, and they can never be reused. New bolts, torqued to the correct specification in the correct sequence. No shortcuts. We replaced the sealing rings on the injector return lines. Tiny rubber rings, a few cents each. But if you reuse the old ones, they will leak. Diesel will weep out of those return line connections, smell up the engine bay, and eventually drip onto something it shouldn't be dripping on. New seals everywhere they belong. Then came one of the more delicate parts of this entire repair: the front crankshaft seal, the PTFE seal that sits behind the front crankshaft pulley. Now, if you've watched the dedicated video on this channel about that seal, the one where I show the custom installation tool I had machined on a lathe, you already know how this went. For everyone who hasn't seen it, here's the short version. The crankshaft seal on this engine is a PTFE seal, Teflon. No spring, no metal reinforcement. It seals purely by contact with the crankshaft journal surface. That means the installation angle is absolutely critical. A misaligned seal will leak from day one, and there's no recovering from it without pulling the seal back out and starting over with a new one. On top of that, once the seal is installed, it has to sit completely undisturbed for 4 hours to cold set against the crankshaft surface. You can't start the engine, you can't rotate the crank, you can't even bump the front of the engine accidentally. 4 hours of stillness. Then it's ready to do its job. The challenge on the 958 platform is that there's almost no clearance around the front of the crankshaft once everything is assembled. Standard seal drivers don't fit cleanly, and even when they do fit, you can't reliably control the press-in angle. So I had a custom tool machined, a lathe-turned aluminum body sized to the exact outer diameter of the seal, with a 2 mm stepped recess on the face that contacts the seal evenly across its full circumference. The bolt pattern for the tool was taken directly from the crankshaft pulley retaining plate, so the tool self-centers on the crankshaft axis automatically. The seal went in perfectly square, zero tilt, zero guesswork. Then we walked away from it for 4 hours and let it cure. Now, do you remember the coolant reservoir job from a few videos back? Same car. After all that oil cooler contamination, the reservoir had oil residue baked into the inside of the tank, left over from when the oil cooler gaskets were failing. There was no point flushing the cooling system if the reservoir itself was still going to be releasing contaminants back into the new coolant. So we pulled that reservoir, cleaned it thoroughly from the inside, and reinstalled it. There's a full video on the channel showing exactly how that tank comes out on the 958. It's tighter than people expect, and the ABS module has to be repositioned to give you enough room to extract it. Check that video if you want the detailed walkthrough. After all of that mechanical work was done, the cooling system needed a complete flush and refill. 10 liters of fresh coolant. Full vacuum fill, not just gravity fill from the top, because air pockets in this cooling system create hotspots, and hotspots create more failures down the road. Vacuum fill, then bleed cycle, then a confirmation that the system holds pressure properly with no air left in the lines. Engine oil was drained completely. 7.7 liters of fresh oil, correct VW specification, 504.00 and 507.00 compatible, which is what this engine requires. New oil filter installed. And finally, a new air filter. Because if you're doing this much work on an engine, you don't put dirty air through it on the way out of the shop. When everything was buttoned up, I started the car, watched it idle for 10 minutes, checked every fitting, every gasket, every connection for the first signs of any leak. Nothing. Brought it up to operating temperature, let it stabilize, drove it on a road test loop. Coolant temperature steady at 90 degrees Celsius. Oil temperature climbing normally and holding in the proper range. No warning lights, no smoke, no smells, no abnormal sounds. Clean repair, customer satisfied. This is the kind of job that takes time, patience, and the right approach. You cannot rush a CRCA engine teardown. Every gasket matters. Every seal matters. Every fastener has to be the correct one, torqued to the correct specification. And if you skip one of those small parts because it looks fine and you don't feel like buying it, you'll be back inside that engine in 6 months fixing the next thing. The car drove out of here running better than it had in years, with all the small failures addressed properly. The cooling system clean, the oil clean, and the customer confident that he's not going to be back next month with another leak. That's the full story of this Porsche Cayenne 3.0 TDI repair. Now, before I wrap up, I want to say something to all of you watching. To everyone who's been subscribing to this channel, thank you, genuinely. To everyone who's been leaving comments, asking technical questions, sharing your own experiences with these engines, thank you. You're the reason this channel exists. Every comment I read, every question I see, helps me figure out what to film next and what kind of detail people actually want. If you're working on a CRCA engine yourself, whether it's in a Cayenne, a Touareg, an Audi Q7, or anything else from the Volkswagen Group with this drivetrain, drop a comment below. Tell me what you're working on. Ask the questions you can't find answers to anywhere else. I read everything, and I do my best to respond when I can. If this video was useful to you, hit that subscribe button so you don't miss the next one. And give it a like. It really does help the channel reach more people who need this kind of content. And check out the playlist on this channel for every individual repair on this car. The coolant reservoir removal, the crankshaft seal installation with the custom tool, and more coming soon. Each one is filmed in detail, so you can follow along step by step. Thanks for watching. See you in the next one.